Hello YouTube, I Fix It All here, Team I Fix It All. What we got here today is a battery that is manufacture date of February of 2022. I bought it in March. I put my receipt right here. It says Napa 322. That's when I bought it. It's been goofing up a couple times over the summer, meaning it appeared like the battery was getting drained or something. I pulled the caps off underneath this label. Most all of these batteries, they call them non-serviceable, but most of the time you'll find out you can service them. Ultimately, what I've done here is I've got a battery charger. This happens to be a power supply for a Coleman 1980s or 90s camping blow-up mattress, DC powered. Actually, yeah, kind of true. The motor that was on the blow-up mattress was DC powered. It could be cigarette lighter powered, or this happens to be the AC power for it. And it's supposed to be a 12 volt power supply, 2 amps. I think that's what it says. Yeah, 12 volt DC at 5.25 amps. You can take a look, see if you like. And I thought that was pretty interesting because with no load on it, meaning right now I have a load, it's the battery. With no load, and with my multimeter, if I can untangle the leads. Well, I don't have to waste time on that. With no load, it's doing right around 15 volts. Now I gotta check. Dang it, why'd you guys do that to me? I'm gonna switch to, this is a great meter, by the way. I think everyone should, who's a techie guy like myself. I've had my hands on lots of high-end meters. I even have, let me go over here and take a look. I have 2 of these. Those are almost $200 meters when they were brand new. But one of these has features that the other doesn't. And then there's this one that was like maybe $30 some, but taking a look at all, it's a Meter Man. Let me see. Meter Man XP 35A. Look at all the functions it has. That's a terrible light. Maybe that'll be better. Not only that, it has this other cool feature, which is you can just wave it in front of the wall, and if you come across a hot electrical outlet or something that's powered up, let me see if it detects this. Yeah, that's the AC input. So if you're running along a wall, you can detect AC wires. But let's see what it is with no load. I'm going to switch to, I want to read DC volts, so there I go. Let's see if you're in frame. And this is with the battery on the circuit. 14.95 volts. Now if I lift one leg off, well, get the colors right, it doesn't matter a lot of times with DC. Now that the charger is not in the circuit, and all you gotta do is just lift one leg off to get that done, what is the power supply putting out now? 15.2. if you can see that or not, but right now there's no load on the power supply. And so I got to thinking, well, why throw that away? Why not keep that? That makes a good automotive battery charger. Well, the purpose of this video today is to do something called investigating a parasitic draw. Parasitic draw is when you have a symptom where you have a battery that seems to die down or doesn't seem to last real well. I pulled this battery out of the riding lawnmower. I pulled the caps to see a couple of things. I wanted to see that as soon as I put the charger on it, did I immediately or within a minute or two would I see the fluid down in there bubbling in one cell but not the others. A normal battery, you might see, if it's pretty drained, some occasional bubbles popping up, but you'll know the difference because it'll be an occasional bubble. It's like there's a bubble, there's a bubble. You're like one every second or so. That's for something, and your power supply will be getting really, really warm because it's sending it amps. There's three things about Ohm's law. It's well, there's a lot of things about Ohm's law, but you need voltage and current and resistance. As a result of the resistance of the battery, we have watts, and watts is dissipated in the form of heat. The less watts, the more efficient something is. When this charger was first plugged in, it was pretty damn warm. It was a good hand warmer. Left it on charge for about, well, I guess it's almost been a full day now. And I'm not really putting out a lot of current. What I do have as a feature on this one is an amp clamp, which means that part there. I can choose amps for an AC circuit or amps for a pointer, Scott. Where's the pointer at? Oh, right there. I can choose amps AC or amps DC. In this case, this is direct current. So I'm going to choose amps DC, and I'm going to use my amp clamp here and make sure that it zeroes out, and it isn't, so I have to go to the function called zero. That zeroes it out, and I should be able to amp clamp on any one of these here and get a reading. And right now it's telling me I don't have very much current draw at all. As a matter of fact, with this multimeter, it's such low current draw that it's telling me it's 0.4 amps, about a half amp. Yesterday, when I amp clamped, I was at about 5.3 amps, which was maxing out this power supply. Way over the top. So it's an interesting topic because this battery is getting drained, or it's not getting charged, and I got to make a decision whether I got a parasitic draw on the lawnmower or if my voltage regulator on the ride mower is not working well. But I've had this same problem on that mower off and on for years, no matter, and I changed the engine out, so that integrated a new voltage regulator as well. About 3 years ago, I put a new motor on and gave it a hell of a lot more horsepower. So I watched the performance on this battery, and I also checked cell voltage readings. And you got to be careful when you do this, but I'm going to go to DC volts, and I'm just going to be checking for if you've got a 12 volt battery. Right now, people call it a 12-volt battery, but when they're under a charged state from the car or the riding mower or whatever, they're in a condition called float voltage. So there's 1, 2, 3, 4, 5, 6 2-volt cells in here, but each cell floats at about 2.5 volts or 2.25 volts, 2.25. They're all in series with each other. So you got 2, 4, 6, 8, 10, 12, 13.5. You can take individual cell voltage readings, and if you just keep your polarity wrong or not, you know, like I can put my black lead here and my red lead there, and I'll come up with a negative. I need another pointer, damn it. There's a minus sign that showed up right here. And it went away. But that minus sign won't be present because I have correct polarity on this way. I switch my leads. Put the red where the red goes, black where the black goes. I'm going to take cell voltage readings because yesterday when I checked the cell voltage readings, they all looked really even. I'm under a charge state right now. I'm charging. I'm expecting to see about 2.25. This one is, I've got woodpeckers beating on my damn garage. This is telling me it's about 2.6. Acid. All right, so positive post, first hole going with positive, and you're moving toward the negative. So you just keep progressing. Remember, this post is soldered to this side of this cell. This cell is soldered to that one, is soldered to that one, is that one, and that one, and that one, up to this post. They're all in series. I just want to make sure the cells are even. This is telling me 2.67. Now I'm measuring the next cell to cell. That was cell 1 to cell 2. Now cell 2 to cell 3. 2.65. Yep. I'm expecting this. 2.7. 2.6. 2.55. You can also go from your ground post and start working this away and see what you've got there on your ground tie to your ground post and see what your voltage drop is there. And I'm getting like a 0.8 to 0.9. If I go from here to here, I'm I'm graduating up to that voltage drop plus this cell, 3.1, 4.985, 8.2 or 3, 10.5, 12.8, and that's source. That's with the charger on. Disconnect the charger. Make sure that stays separated so they don't arc against each other. From that post to that cell is 2.27. Four, 0.1 probably. 6.28. 8.5-ish. 11.3. 13.1. 3-ish. And here we're at 13.58. I don't have the charger hooked up right now, so the battery's decreasing in voltage. It's going to settle in right around what I hope to be about 13.25, 12.9 to 13.5. Somewhere in there. Right now it's doing what I expect. So cell to cell voltages. We've got oops. Yeah, okay. Normal. Good. All right, so this is probably going to settle out with no charger on it. These are going to settle out. These cell readings are going to probably settle out right around 2.3 volts. You just want to make sure they're even. Right now I've got 2.44. Let me check the first one again. I want to make sure they're even, they're balanced. .44. So hard to get sometimes. .3. Oops. Yep, 2.3. 2.3. Maybe the battery's still unloading a little bit. Okay, this one's coming down a little bit. A little tad high on this first post. It's coming up 2.39. See what we got from here to here. Okay. From here to here. Yeah. I would expect them to be about 2.25-ish. Okay, so that's a quarter, 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 quarter. That's 1. Quarter, quarter is 0.5. So 2.25 times 6 is 13.5 volts roughly, with a battery that's been sitting on the shelf for a few days. I'm probably going to end up with, if I let this sit overnight, it would probably end up reading out with no battery charger on it about 12.9 to 13.1-ish, and it would set like that. But anyway, we're going to do a parasitic draw test. I just now traumatized the hell out of the battery. Got the charger on. Amp clamp it. See how many amps we got going on here. It's telling me right now, oh, I didn't clear it. Hang on. Like a half an amp. Let's assume this battery's in the lawn mower. Right now we know in this condition we have the battery getting charged. But a way you can test for a parasitic draw while installed in the machine that the battery's living in, you could do little light bulbs. Let me get another one here. You probably start out with a really healthy light bulb. If you've got a hell of a battery drain, then you might want to start with a larger light bulb. Because if you do these as test lights, that's what we're doing. it's called a Noid test. But if you've got a little test light here on a socket that came out of something, it could even be an AC bulb too, but not an LED. It's got to be an incandescent type bulb. Start off with something robust. If it's a really quick draining of the battery, with your keys out of the ignition or the lawnmower off or the device off, you want to lift one leg, either the positive or the negative, and I would probably say your instinct tells you to go for the positive one. I think mechanics want you to use the negative. I'm not a mechanic, but I could be. Let's just use the negative leg and see if we can get this light bulb to come on. I'm putting the light bulb in series, basically, with the negative battery post. See if I can get the bulb to come on. And I can't. A little bit of information on batteries. When a battery is charged up completely, and it's a proper battery, it isn't a load on your alternator. It is not a load. That's called, when a battery is fully charged, it is floating at what the alternator is providing while at idle, which is going to be about 13.5 to 14.2-ish volts DC. 14.2 is where you want to be. Trust me, if you start getting lower than 14 volts on your alternator, you need to start planning for an alternator soon, or get the regulator or the brushes repaired or changed out. So a battery, when charged, acts like an open circuit. It's like the light switch has been turned off. That's what a light switch is. It's a metal bridge that opens the circuit. There's still power coming in. There's still potential coming into one side of the switch, but there's no current flow because there's no bridge. Well, similar to a battery's case, whereas by way of chemicals and chemistry inside the batteries and the plates and the anode and cathode of each plate, batteries will make a simulated electrical bridge. Batteries are like open circuits when they're fully charged. They are no load on the device charging them. This power supply here, there's something getting in there. There's some sort of power going in. It's probably very small because this is barely warm. I'm going to find out just exactly how many amps are coming in there. This meter is capable of doing the job if I put my meter in series with this circuit. Right now it's a series circuit. I have a charger. A wire goes in one side of the battery comes back around, and it comes out the negative side. That's a series loop. If I put my meter in series with this power feed, I can read the amperage. This meter can do several different options in amps. One of them says, let me look here. Dang it. Oh, there we go. It's got amps DC, amps, and then the DC symbol, milliamps, and the DC symbol, and milli is 3 places to the right of the decimal. Like if you put a decimal point, and then you go 0, 0, 1. That is 1 milliamp. Because in order to, that's a number less than 0. So if you move your decimal place 3 places to the right, you come up with 1 in MA. 1 milliamp. And then there over here is microamps. Micro is 6 places to the right of the decimal. I'm going to choose the highest option first, which is just pure whole numbers amps DC. That's safe because that particular symbol, I'm choosing a circuit in here, and that circuit is engineered to handle full whole amps, you know, like 20 amps or two. And this meter ain't going to handle 20 amps, I guarantee it. But I could say it might handle 10. There's a circuit dedicated to handle 10 amps. I'm going to start with the highest capability and move my way down until I find out how many amps is the battery currently consuming to reach that completely full belly state, full in amps. They don't need to get full of volts. They need volts and amps. And I'm going to disconnect the positive and hook my negative lead up to it. I know that might sound counterintuitive, but what I'm doing is I'm putting my meter in series with the power leg coming into the battery. And I'm currently getting no amps reading. I'm going to step down to the next lower scale, amps. Will I get a reading here? What is going on? Should be getting something. I don't know. It don't seem right. Microamps. That's no good. What's happening? I think we got a meter malfunction, people. Well, wait a minute now. Let's test light it. Let's see if I have any current going in. I'm going to use my meter. Let's use a test light. I'm stepping down to the next smaller test light. This is what it looks like if you have a parasitic draw in your car. You have your car off, and you just disconnect one side of the battery, be it the positive or negative side. And then you got a test light here. This is goofy. Okay, I do have a little glow in there. It's so tiny. I'm going to use this little test light here. Yep. Okay. See if I can get you guys involved in that. I hate this stuff. Here we go. Let me grab the camera here. I'm lifting the lead off. And boom. Back on. You can see what I got there. I've got the test light. That's how many amps this thing is drawing, which is like really hard for any kind of meter to detect. You almost have to have a test light. What I did was I ensured that all of the options I had for the meter, I should have been able to read that though, on microamps. The meter says it's capable of doing microamps. It's got to be more than micro. Just that symbol. should be able to read this. Dang it. And wrong. Maybe it was polarity. Come on. That's DC. What's going on? Why are you not working? Range. Push the range button. I'm going to go here and hold the range button. I wonder if it helps if I read on the other side. I don't know why it would. It doesn't make any doggone sense. Why would this be better? Don't understand why I'm not getting a reading. Wasting your all's time. That is DC milliamps. I should be able to read point something. Even on micro. It's telling me I got reverse polarity. No, it wasn't. Oh, shoot. Guys, sorry about that. To read amps, well, this is about to make progress. I screwed up a little bit. In order to read amps, most of the time you have to move your positive lead of your meter. Because you got to read the meter. Yeah, Scott. So this socket here tells you that it's designated for ohms, volts, diode, hertz, and temperature. This middle thing is called common. This side over here is reserved for amps, milliamps, microamps, and capacitance. I think that's capacitance. Yeah, capacitor symbol. So now we're going to get the real reading of what we're doing over here. I'm going to let me see. Yeah, okay. I'm on amps now. It doesn't matter what lead on the battery you interrupt. Just interrupt one of them. And put your meter in series with it. And pay attention to what your meter can handle as far as amps too. Because a lot of these meters can't handle nothing but just maybe a half amp. 5 amps. All right, so I've got my meter technically is in series with the ground leg. And it's telling me I've got move the decimal point on this one. 3,850 microamps. I'm going to go to milliamps. I should have started out on the largest scale. This is the highest capacity amp reading here. Yeah. It's going to settle in. Because the meter has to tune to what it's reading. It's a highly calibrated circuit. For amps is always an expensive feature. If you buy a meter just for amps, you're going to be paying for a meter that, like those meters over there, can do, for the DC side, they can do lots of amps. 3, 4, 5, 600 amps. Right now, it's telling us we got like the battery itself is only hungry for about 0.2 amps, 0.3. That's if you move your decimal point to the another pointer, please. If you move your decimal point to the right 3 places, milli is 3 places. 1, 2, 3. You could reasonably say it needs about 350 milliamps before it's full. Well, that's nothing. All right, so that stands to reason why such a low amperage. That stands to reason why we could not get the big why we couldn't get this big bulb here to illuminate. We can make the big bulb illuminate if we go from here to here. Yep, that did that. But if we want to use the bulb to tell us anything, any information, we've got to put the bulb in series with one of the leads going to the battery. All right. So I'm going to find out if I have a parasitic draw on my lawnmower or not. I've already made a hell of a long video here. Let's use this little test light here to see if we can get anything to read. Any illumination. I think we're going to have just a itsy bitsy. I can see it. It's lighting. I don't think you guys can though, but it's barely illuminating. I'm going to pause the video and we're going to go put this out on the lawnmower, the battery itself, and then we're going to bring test lights to see if we have an illumination with the lawnmower not running. We're going to see if we have a parasitic draw on the lawnmower. Hang tight. So here's the test case lawnmower right here, the one that I couldn't start yesterday. And that's my new engine I put on it a while back. And that's where the battery's supposed to go. I'll get you guys set up. Hang tight while I put the battery in. Alright guys, I got my battery seated in its hole. And I have my negative cable hooked up and it's cleaned. And here's my positive cable. This is forget what size it is. I think it's 2 gauge or 4 gauge THHN or RHH RHW with a Burndy, what was a 2-hole lug converted into a 1-hole. So I'm not seeing. Let me see. Okay, yeah, here we go. So I can go for my positive battery cable, set my meter on amps, and see what we come up with. And I'm getting, I don't have a light for y'all. Nothing. I can go to milliamps, and I'm coming up with 0.63 milliamps, which means if you move your decimal point to the right 3 more places, that is 630 microamps. Let's check that. And that is 612 or 13 micro. A little upside down U there is micro. Sorry about the light. And of course it's telling me I have my polarity wrong. Okay, well, doesn't matter. I don't understand. Let me see here, because I don't have a fault. And there should be a fault somewhere. Unless the regulator's been bad from day one on this newer engine that you guys are currently sitting on. There's not enough energy right now being bled out. Hang on for a second. Let me touch this. What's going on? Okay. Okay, I'm just confusing myself here. Maybe my accessories relay doesn't, or my main power delivery relay doesn't kick on until I have the ignition fired up and engine running. Which means this battery is totally disconnected from every damn thing possible, except for that mysterious 630 microamps, which is nothing. I got a little bit more digging to do, but that's the end of this video. I don't think there's anything here useful other than using a test light like so. Because currently my key is off. You can't see my key. I'm not going to move the camera because it's like you guys are really rigged up. But I've got a test light, the same one we were using in the garage. It's a little bit bigger one. You can take a test light, one end of your battery cable, and go to the other end. And if it comes on with this kind of a bulb, you have a problem. All right. Now the other test light, which is a lot smaller, with computer-controlled vehicles, you might get this one to illuminate just a little tiny bit. That's because it's called the KAP circuit, the Keep Alive Power circuit on your computer. But right now I'm not getting no illumination on this dinky little light bulb here. Forget what these called, what number they are. I don't really need to know. I'm just, by scale, you can see how big they are. They're little guys. I've got the number written down in the bin they've come from in the garage here. This is the kind of bulb that really helps you track down. So what do you do next? If you did have this bulb come on, one at a time, you start pulling fuses until you make that light go out, or pull relays. Keep track of what you're doing though, one thing at a time. Once you get the light bulb to go out, that tells you what sub-circuit to focus on. Parasitic draws are not hard to find. It's just making sense of what's causing the drain. And suddenly, you pull this little trick out of your hat because, you watched a YouTube video on parasitic draws and there's 1,000 of them. You discovered that when you unplug the interior lights fuse, this test light goes out. That means you have found the circuit that's faulty or has the issue. And come to find out, it wasn't a faulty circuit at all. It was someone left a light on in a compartment somewhere inside your SUV, and you didn't know it was on. And it's a switch controlled light or something to that effect. Or there's a cigarette lighter adapter somewhere, and underneath the boxes of everything in the truck you have or van you have, there is a toy that's charging that drains your battery. Hard to tell. But as soon as you make this light go out by pulling a fuse or pulling a relay, read what the fuse box label tells you that is, and either continue diagnosing or relay that information to the mechanic that's about ready to start working on the vehicle. It'll save you a lot of money because he's got to go through the procedures like you just went through, and you can save yourself a lot of money too. All right, have a great day. That's the end of this video. I've just got to figure out what the hell my issue is with this. It's not just this battery. It's like every... Maybe they were right at Napa when they said, well, when I was asking about the warranty on these, because I think the warranties are only like 90 days. I said, 90 days? Are you kidding me? He goes, yep. I said, why is that? He says, well, lawn and garden batteries don't last for shit anyway. So maybe it's just the lawn and garden battery, and I got to find a... Maybe I'll do a Maxwell supercapacitor battery in this lawnmower. That would be inexpensive and fun. All right, guys. See ya.